Alright, so let's read this question. The question states that a chord of a circle is 32 centimeters long. A chord of a circle is 32 centimeters long. The distance of the chord to the circle of the chord is 12 centimeters. You have to calculate the radius of the circle. That's question number 1. And you are also supposed to calculate also the length of the chord, which is 14 centimeters from the center of the circle. So looking at this as a solution to the question, let's draw our diagram this way. So we are going to be having it this way. We are told that a chord of a circle is 32 centimeters long. So this is a chord here. I'm going to draw this place as 32 centimeters. So let's call this chord AB, which is now 32 centimeters. We said the distance of the chord to the center of the circle is 12 centimeters. So definitely there is a center here. So we are told from the question that the distance of the chord, the distance of this chord to the center of the circle is 12 centimeters. So from here to this point is actually 12 centimeters. Well, we know a straight line drawn from the center of the circle to the middle point of a chord which is not a diameter is at right angle. So with this, we have been able to show this. So we are asked on the question to calculate the radius of the circle. If you have to calculate the radius of the circle, definitely I can just as well just close up this one, then also close up this one. So the radius is the radius, this is also radius. So this is our O. So if here is 12 centimeters, if this one is 12 centimeters, if let's call this place D, if here is D, if your OD, let me put it this way, if your OD in this case, if your OD is 12 centimeters, if OD is 12 centimeters, definitely I can just split this one. Since I know that AB is 32 centimeters, so 32 divided by 2 will give us what now? Here will be what now? Here will be 16 centimeters, and here will also be what now? 16 centimeters. So to find the first question, we have to find the radius. We can just apply Pythagoras theorem. We can apply Pythagoras theorem to answer that particular question. So apply Pythagoras theorem for A. We have to apply Pythagoras theorem. Pythagoras theorem to find the radius. So we are now saying that our OB square, which is what I'm saying here, our OB square is equals to, we can say OD square plus DB square. So what's our OB now? Our OB is what we are looking for, which is our radius. Let's label that place as radius. Which is our radius. Let's call this place our R. So our radius here is equals to OD square, which is 12 square plus 16 or square. So and we know that our 12 square will give us 144. 12 square will give us 144. And when we talk about 16 square too, 16 square will give us 256. So 12 square is 144, while 16 square will give us plus 256. That is our R square. So our R square is saying that we are having R square to be 144 plus 256 So what is 144 plus 256? That should give you 400. So now we are saying that our R square here should give you 400. So what value of R? R is equal to square root of 400, and R is equal to what now? To 20 centimeters. So that means the radius here is 20 centimeters. So that means for question number 1A has been what? Has been solved. Now for question number B. Question B says that you are also supposed to calculate the length of a chord which is 14 centimeters from the center of the circle. Definitely we should know that these two are what? Are equal. So if you have to calculate that, that means we can create another chord around this place. Let's label that chord, since I've used D, let's label this one as our M. Let's label this place as our what? Our N. So we are asked from the question to calculate. We are asked from the question to calculate the length of this particular chord. And if you have to calculate the length of this chord, which is 14 centimeters away from the center of the circle, so the distance of this chord now, the distance of this chord is actually 14 centimeters away from the center of this circle. So now I know that this length here is equal to this one. So let me label this space as P. I will label this space as P. And I know from my definition that my NP is half of MN. I've shown it before. That my NP is half of NN. In that case, if I know the distance here, I will know the full distance of this question. That means MN indirectly is 2N what? 2NP. That's the meaning. Now we are saying that our MN is 2NP. So with this, and I know that the radius in this particular circle has already been found as 20. So here cannot be my what now? This point now. That means here can be what? 20 centimeters. So now to find my NP will now be, I am supposed to, that means for B part of the question, I will apply Pythagoras theorem again. Apply Pythagoras theorem. I'll be doing that again. So if I'm to apply Pythagoras theorem, this is the hypotenuse. You can see it's the longest side here. So the hypotenuse here is saying that is 20 all square is equals to NP all square plus OP, which is what now? Which is plus 14 all square. So my NP all square is equals to 400. Okay, let me just have it as that is 20 all square plus 14 all square. That is what we are going to have here. So if we are talking about 14 all square, that is 20 square. So we are saying that this one will give you, that is 400. I made a mistake here. That should be my minus. Here should be minus here. That will be 400 minus 196, which is going to be our what now? Our NP square. So our NP all square is equals to 400. We are having it as 400 minus 196, and that will give you exactly 204. That is 204. So your NP in this case is the square root of 204. So NP is equals to square root of 204 will give you 14 points. We give you 14.2 from 14.28 centimeter. 14.28 centimeter. So that means the distance from this point to this point has been calculated to be 14.28. That's the distance here. The distance from here to here has been calculated to be what now? 14.28. If the distance from here to this point is 14.28, so what's now the distance of this point to this point? Remember that we said that our MN is twice NP. So we are now going to come back here and say, recall that MN is 2NP. Recall that MN is 2NP. So we are now saying that our MN is equal to 2 times 14.28. 2 times 14.28. And what is 2 times 14.28? We give you 28.56 in what? In centimeter. So this question now has been answered. So the question says we have to calculate also the length of a chord, which is 14 centimeters from the center of the circle. Remember what we said? Equal chords, theorem 3, equal chords are what? Are equidistant from the center of the circle. So this is a clear indication that explains that theorem 3 as the case may be. So this is example 1. I will pause this video and also make example 2 for every one of us to have a proper understanding of it. Thank you.